Hey everyone, I'm Alex Griggs, and today I'm excited to walk you through deploying Mozilla Hub's Community Edition on AWS using my Helm charts. Whether you're setting up a personal edition or a large scale event, I've got you covered. Let's dive into this. Let's start with an overview of Hub's Cloud Community Edition. It's the next step in the evolution away from Hub's Cloud. And the best part, you can now deploy it on any Kubernetes cluster. And in this video, we'll be using Amazon's EKS and Helm, which is a fantastic tool for managing Kubernetes applications. Before we begin, we need to make sure we have all the prerequisites installed. So if you're following along in the article, just make sure that you get kube control, AWS CLI, EKS control, and Helm all installed on your machine before you continue with the article. Okay, let's start by creating the necessary file and running the necessary commands to set up EKS. This current file here needs a little bit of a modification because EKS creates the VPC and we will be adding the security group after the fact. I will be updating this article to reflect that. Um, but let's continue and actually get EKS installed. So as you can see, I copied and pasted the EKS cluster config YAML file earlier, and I just removed the bottom part with VPC and security group. The command is already copied and pasted here. What this is going to do is it's going to go out to Amazon, say, hey, create me a Kubernetes cluster with these node groups, and then spit out the needed credential file, which we're calling kubeconfig.hubs-ce.yaml. So let's run this command, and it will go and start creating our cluster. This could take a few minutes as Amazon is running through all of its needed setup stuff. So we just have to be patient and wait for it to be created. As we wait, we can double check that things are working correctly by jumping into Amazon and just going to CloudFormation and looking at the stack. We get all of our outputs, all the events that are happening, everything it's doing. Looks like everything's going the way we want it to. So we're just gonna have to keep waiting.
A few minutes later.
So our EKS cluster has now come up. We can double check this. If we just go into CloudFormation, we can see the EKS cluster has come up and our node group has come up. We will also just quickly jump into the Kubernetes clusters. We're just gonna double check. So it looks like we have everything set up the way we need. So one thing that we need to do to make sure we're production ready is we're going to come into these add-ons and we are going to add the ESF add-on. We will also want the core DNS to make sure that we have a internal DNS. So select core DNS and also select the ESF driver. And then we will scroll down and go next. We will just leave these defaults and go next. Okay, looks good. Let's create those. All right. So those are going to take a minute to create. Right now we don't need them because we're going to jump into RDS and create a external database for hubs to connect to. So we're going to jump over to our RDS tab in Chrome, and we're going to open up the DB clusters. We're going to create a DB. We're going to select Aurora Postgres SQL compatible. We're going to come down here. We're going to make sure we're going to use the latest version 12 because that's what Hubs ships with. I'm also going to use the dev test for this. I don't need the scale of a production system, but if you do, I would recommend running a production instance. I'm just going to change the name to Hub CE Demo Database. We're going to create a new user. So I've created a unique password for my master account. So I'm just going to leave all this stuff default. We're going to change this to the smallest instance, mainly because I do not need the scale right now. If you were running an event, you may want a T3 large or something bigger, but just know that this is going to cost you more money. I don't need replication. We are going to leave all of this default except for switching the default availability zone. We are going to not make this public, but we are going to, and we're going to create a new subgroup. We need to have a security group for this cluster so that we can allow EKS to access it. We're gonna just call this Postgres. I have no preference in where it lives. We're gonna leave everything else default. We don't care about Babelfish right now. I'd recommend just leaving everything default for now. Leave the monitoring on. And as you can see, this is going to cost me about $61 a month. So we're going to go, okay, no problem. Let's create that. We're just going to wait a minute. So we now need to wait for this instance to come up. As we wait, we can just come back and double check. But our add-ins, yep, both our add-ins are good to go. So now we should jump back into the article where we will configure this in the render Helm file shortly. But first, we are going to install Cert Manager into our Kubernetes cluster. Cert Manager is awesome because it'll just automatically update our certificates for us and we don't need to worry about it. So we're going to copy this command. We're going to jump in here. First, run this command so that we can set up our EKS cluster with the correct config and just double check it. Yep, looks like we're good. Okay, so we're gonna clear that. We're now gonna run this Kubernetes control command, which creates the new security group that's needed for Cert Manager. Okay, so we've created that. Now let's go back to the article and we need to run all of these commands. This one will add the Jetpack repo to Helm. A lot of these commands I have already run, so you will be seeing them complain that it is already there. But you just know that you need to update or add and update these repos. Now that we've done that, we can actually install Cert Manager into the security namespace. I'm also adding the custom resource definitions that uh, cert manager needs. We once we have installed our cluster issuer YAML file, or actually applied it, not installed it, that will allow this default to work. It's not going to be an issue when we run the install. Just know that these names need to line up with our cluster issuer. So give it a minute and Helm should kick in and actually install Cert Manager for us. And as we wait, we will jump back into the article and we will scroll down. I'm going to grab this config and we are going to create a new file. And we're going to call this cluster issuer YAML. Okay, so we'll paste this. You will want to replace this with your email. I'm going to just show you an example. Um, this is not what I'm going to apply, but just know this should be a valid email. Go ahead and actually update our cluster to include the new cluster issuer. We'll run this command, and as you can see, my cluster issuer has been created. We can double check this by running this command, issuer, and yeah, we have a new cluster issuer that's ready to go. So we're ready to move on to the next step, which first we're going to need to clone the repo. So let's clone the repo. Next, we're going to want to move our values.yaml file. Oh, we need to cd into the correct location. We will now copy the values.yaml into a new file so that we can modify it without worrying about any updates to the default code. So now that we've created that, we need to actually go into this file and update a couple things. First and foremost, we need to update the hub's domain. So we're gonna come in here and add this. And we are gonna add an email. This is gonna be the admin email for when we try to log in the first time. So because we set up or added the ESF driver, we are going to want to enable persistence. But first, we're going to go through the article and get everything set up so that we're ready to install. So we need to now open up the render underscore Helm file, and we're just going to give ourselves a bit more space here. But if we scroll down, you can see we need to set up a couple things in here. First is our Guardian token, which can just be a random string, and also the same thing for our Phoenix token. I'd recommend creating something a little bit better than just gibberish. But at this point for this demonstration, this is going to work. The node cookie, we also should create some sort of unique identifier. Our RDS instance is up. We now need to move the password and we need to update our external DB host, which we can get from right here. Just grab the top one, the writer, and we're gonna add that as our external DB host. Now I'm going to quickly update this to gmail.com. Okay, so I'm now gonna add my username and password um, for Gmail. Um, these should be equals. This is an app password. I have two-factor authentication on, and I will be deleting this password. So let's just jump back into the article, make sure we're not forgetting anything. Um, so you have a couple options for email. You can use SES. If you're going to use SES, you need to set up your domain, verify it, and then go through the process of creating STMP credentials. Make sure that you're using the actual SMTP credentials, not the user's secret, because it won't work. And once like updated those, the username and password and also the host, you'll want to run this upgrade. This is only if you've installed the chart already, which we haven't yet. So we will be following this, but we're using the install command instead of the upgrade. We can get ready to actually deploy this code. Um, so first, I'm going to create a new namespace, which I'm just gonna call HCCE. Oh, I'm in the wrong folder. So now that I've created that, we should have two user-generated namespaces. So you'll see that there is actually quite a few that Kubernetes creates automatically. You don't have to worry about those. We're just going to be dealing with these two. Okay, so our config looks to be ready to go. So let's now run the needed file. We're gonna just jump back into this folder. Um, we're gonna run the render file. Okay, so we want to copy these environment variables into our EKS file. So now that we have that, we can save that file. And we're going to want to grab the two default certificates as well. So we're going to just copy that and we're going to come here and we're going to overwrite those. Just fix that. Okay. So we now have our values dot or dash eks dot yaml ready to go. So the only thing that we're going to want to change eventually is the persistence. Because with the persistence, we're going to have to set up a file system, which we might as well just do right now. So let's just jump into folder here. We're going to open up ESF. We're going to go to file systems. We're going to create a file system. We can give it an optional name. I'm going to just call it storage. We're going to want to change this so that it's in the same VPC. And we're going to click create. Okay, so now we need to copy this file system ID, which is what we need to add right here. So we're going to add that. We're going to enable it as well. So what this is going to do is on install, it's going to grab this file system ID and create a new drive for either Postgres or Rectilium. because we have set up RDS, we don't need to run a local copy of Postgres. So one of the benefits of Helm is that we can actually come in here and add an enabled flag and change this to false. By doing this, we're actually updating the dependencies for the stack. As you can see, it defaults to true, but by turning it off, we're actually going to turn off this entire subchart. So PG Bouncer is actually going to connect directly to our post or our RDS instance. So let's just quickly jump back to the article. And because we've done this step and we've already followed through on everything else, we should be ready to run our create. So my setup's a little different than the way you're gonna do it. I have to run mine from this main section because of how I set up my kube config. So we are just going to add the location of that file, and then we're also going to say that the chart files are there. So I need to install this into the HCCE namespace. And by hitting enter, we are going to run our install. If you want to see the YAML output from Helm, you can add --debug and or --dry run. Both will, well, debug will give you the YAML files, and the uh, dry run will only output it won't change the cluster. Obviously, it's a dry run. So as we can see, the Helm chart says it's deployed. So now what we need to do is we need to grab the name or the external IP, which for Amazon actually is a DNS record. So this is a older type of load balancer. So what we're gonna do is we're gonna jump into our hosted zone, and we are gonna update the 4 DNS records that I have already created. But on Amazon, it is really simple. All we do is come in here, we edit this, and it is an alias. So we want to pick the right one. Uh, it would be this one, I believe. Yep, looks right. So we're just gonna update that. I'm just gonna jump back and double check. Yeah, okay. So we're also gonna update this record. Second, save that. We're going to update you. And last but not least, the stream. So we need to update you. Okay. Now that we've updated these things, we can jump back here. We can close out that command. We can run a kube control get pods, and we will see what pods have come up. Oh, I did not save our values file, so I need to run a Helm upgrade. It is very similar to the last command we ran. We just need to give it the name, the file, and the location of the chart. And we're going to just run this again. And this should upgrade the chart and remove the needed, or once we update the chart, it should remove the Postgres instance that Helm is creating, as we don't need it. Okay. So now let's check that again. And as you can see, it is terminating the internal copy of Postgres, and we will shortly not have it. Now, it looks like we're having some issues. Let's just check our certificates first. Make sure that we have those. Okay, we have all of our certificates. So if we jump into Chrome, we open a new tab. Sorry, just give me a second. We're gonna just jump into here. As you can see, we have our default certificate still. I'm gonna just accept it, and Rectilium is down. Okay, so we need to jump back in here, and we need to figure out why Rectilium is not giving us what we are asking for. So we're gonna just check the logs quickly and see. Okay, we're still stuck in creating, which is interesting. So we're gonna describe this pod to get a bit more information. At this current moment, it looks like Rectilium cannot mount the persistent volume. So we need to jump back into the article and look at how we set up the actual persistent volumes. So one of the things we need to do is we actually need to update the security group to allow EKS to connect to our ESF file system. So what we're going to do is we are going to run a few commands which will allow us to enable a trust between the two services. So as you can see, we got to run a few commands. So I'm going to just jump over here. I'm going to paste this. We're going to edit the name because this should be Hubs CE demo. And once we run this, we should have two new environment variables that have been exported. So we can now come over here and create a new service role or service count with the correct roles and approve it. So we're going to do that. Um, I need to change this. Okay, so let's run this command and see what happens. Okay, so it looks like we are missing something for our cluster. So let's just quickly run that command. Unable to describe control panel. Yep, that would be because we need our profile, and that should be hubs. Okay, so we have now added an IMA OpenID Connect provider. We should run this with proof, and that should enable it. Okay, so now we can go back and actually run our service provider or our service account. We just gotta wait for this to complete. And we'll jump back in here. And we will actually run a few other commands. Get us where we need to be. We're just gonna wait for EKS and CloudFormation. Okay, so this error is actually because the role already exists, and we can actually check that in our CloudFormation. As you can see, it's returning an error because the role already exists. Um, so we need to um, jump over to. Let's go to ESF. We need to look at the file system. We gotta go to network. We need to grab this ID. Now we go to EC2 and security groups. And then we're going to search for the group we just looked for, which seems to be the default. And now we need to edit the inbound group and add all traffic from our node group that we want to allow. So once we've done that, we go back to our setup here. We can get some pods. We should be able to delete this pod. And then the new one that comes up should grab ESF. Let's just describe pod. And there you go. We're up and running. Looks like that is working. So let's jump over here and check and see if we can get to the website. We're gonna just reload. Does not look like we've come up yet. So we're gonna describe this pod again. Looks like we are having an issue. We should check. Okay, so it looks like our RDS instance is being blocked. So we are gonna have to jump back into here. We're gonna go back to our security groups. We're gonna open up the Postgres one that we created because as you can see, it's only open to a public IP address. So we're gonna come in here. We're gonna go PostgreSQL, and we're gonna do the same thing. We're gonna allow the node group to have access to it. So by doing that, we should now see that PG bouncer, if we remove it, we should let's just pull up all the pods. And as we can see, we now have a new PG bouncer. So let's just take a look at the logs and still can't connect. Why is that? Fatal. RetDB does not exist. Due to the fact that PG Bouncer can't connect to the database we need it to, due to the fact that it does not exist, we're going to need to come back into our Helm file and scroll to the bottom, and we're going to update this so that we can see, or we can get PG SQL, the pod to come back up. So we're going to run Helm upgrade Moz We're going to point it at the right value file, which is right there. We're going to give it the chart files, and we're going to give it a namespace. So we're going to upgrade this, and the Postgres SQL pod should come up. Once we have that, we'll be able to execute into that pod and connect to our database or our RDS cluster. And then from there, create the table. And if you want to, you can also create a user, and I'll show you how to update the credentials once you've done that. Okay, so our chart is updated. So let's take a look at the pods we have. Okay, so our pod is still pending. So we'll just have to wait a moment and it should come up. While we wait, we will set up the command we need to get into this pod, which is something along these lines. We can run this and don't have a assigned host yet. So we're going to have to just keep waiting. This doesn't come up. Should probably do a describe. So there must be a reason why this is coming up. So one of the issue we're having right now is some sort of mix match because we turned off PG SQL. So the easiest way I've found to resolve this sounds crazy, but bear with me. What we're gonna do is we're gonna run a Helm delete Lowe's and add our namespace. We're gonna delete this Helm chart. And what this is going to do is it's going to go through and it's going to remove everything that we've installed. And as you can see, we've successfully uninstalled the Helm chart. So we can actually run Helm ls and check, make sure, yeah, we have no Helm chart installed here anymore. If we go to our website and double check this, refresh, you should see it doesn't resolve anymore. So the reason why we've gone and done this is because we wanted to make sure to remove all of the uh, persistent volumes and persistent claims that could exist here. As you can see, it looks like those have been deleted, and yeah, we're good. Okay, so now that we're back at default, we need to just run the Helm install command again, and this will set up everything again for us. And we don't need to worry about cert manager because it's still installed and intact. And this will just install the hub stack back onto our system for us. So we're just going to run this command. And this will install everything for us again. Would only do this if you have no data on the instance. If you run the delete command, it will remove everything on you. Okay, so now that we have that up, let's get all our pods again. And there we go. As you can see, the PG SQL has now come up. And looks like everything else is starting to come up as well. So let's now execute into Postgres. So we've now executed into the PG SQL pod. And what we're going to do is we're going to run a command that allows us to connect to RDS. So we need to use the dash capital U Postgres because that's our password in our file right here. So that's the username we want to use. We're going to copy the external database URL, and that's going to be after the -h, and then we're going to hit enter. Now we're going to copy that password we added to our render underscore helm script, paste that in, and look at that. We've now logged into RDS. So the next thing we need to do is we need to go ahead and actually create the needed table. To do that, we need to run a few commands. So to create a database, we need to run this command, which is create database ret db colon, and that will create the database that Victilium needs. Now we're going to create a new user as using the master username and password for your RDS instance is probably not what you're looking to do. So what we're going to do is we're going to add a new user called ret with encryption. Oh, sorry, with encrypted password. And I'm just going to call this my pass. I would recommend changing this to something more secure. But for a demo purpose, this is totally fine. So the new role has been created. We are now going to grant the needed database privileges. We're gonna give ret db to ret, which is the user I just created. Oh, we got semicolon, and we've granted that. Now, this setup we're gonna change in our Helm chart to reflect the user we just created. So we're going to now exit, and we can exit out of the execution here. I'm going to just make sure that we have a copy of this. It's going to be my pass. We're going to duplicate this, make this ret, close that, save that. And we have two options here. We can either update it in the render home, or the thing I'm going to do is I'm going to actually edit it directly in my values file because this is what my source of truth is now. So this is going to be my pass and ret. So I'm going to save this. I'm also going to come down here and I'm now going to turn off Postgres because we don't need it anymore. And then we're going to come into our terminal and run helm upgrade moz. I need the values EKS. Gonna point to the helm chart and give it a namespace. Now we're gonna upgrade this. Or running this script should now produce a hub stack that is connected to RDS and has persistent volume claims. Now fully set up the new helm chart. One thing that we should definitely make sure of is that we grab the new service. This load balancer has definitely changed on us. So we need to jump back into our Route 53. Just gonna quickly modify these. Yeah, our stack now needs a different load balancer. That looks, let's double check that. We are looking at should be this load balancer. Save that. Come back here. We're going to edit this. We will save that. We're going to go and save this one. Okay. Now that we've done that, we should be able to come back here. We need to wait a few minutes for our DNS to resolve. But we can come back in here, get pods. Looks like Actilium is up, but let's just double check that with logs. Looks like we went through the migration, meaning we should have all our data now being saved to RDS. Let's go back to our web browser and run a reload. Gonna have to wait a few minutes.
One eternity later.
After waiting for the DNS, we now have access to our hub stack. I'm just going to quickly log in into the admin center. So we're going to use the admin email that we put into the Helm chart. I'm going to click next. I'm not going to show you my email, but just know I am going to jump in there right now. I have received the email. I'm going to come up here, paste in the link, and log in. Cool. So now that I've logged in, you can jump into admin and look at that. We have an admin center. I am going to just quickly import some scene packs that I already know about. And we're going to only import a single scene because this is demo. Cool. So the gathering hall has now been set up. We're going to grab a single avatar so we have something. And we're going to import that. So now we have an approved scene. We can jump into a room. Cool. So we can now join. Give it a second. Looks like we have an avatar. All right. I'm going to allow. Make sure my audio stuff is set up correctly. I'm going to join. Cool. Skip the tour. To quickly check and make sure our audio is working without another person in the room, we're going to turn our TC panel. And looks like we have connected to dialogue. I'm going to create a new tab off screen and join the room. This should prove to us that we have an audio connection. Because as soon as this new user joins in, we should start seeing some changes in our TC panel. Okay. So we have another user in the room. Looks like we have a local producer and a receiver transport. So I'm going to quickly unmute one of these tabs and see if we have some audio. Just gonna double check. Yep, we're using the right audio output. Hello? Okay, so just to double check that we've connected correctly. Hello? Okay, it looks like we have an issue. Let's take a quick peek at Reptilian's logs to get a better idea of what's going on. Looks like everything is working. So I'm going to quickly look at the dialogue pods logs. That's a tongue twister. Well, one thing we should double check is that we have the correct ports open because we might be missing a port or two. So we're going to jump in here. We're going to go networking. We're going to go to our security group. And we're going to look at the demo node group, this one right here. So as we can see, we are only allowing traffic between this security group and two other security groups. So to quickly get this working, I'm just going to add in the ports that we need. Modify inbound, this guy. We want to allow it from everywhere. And then we need to come back here and we need this port range. So custom TCP, yep, those are good. Now this should be custom UDP. This is a range. We're going to add it there. We're going to add that. And we are good to save this. Now that we've saved that, we should be able to connect to dialogue. And look at that. As soon as we switched back, we now have a remote and a local candidate. And it looks like we have audio now. So let's quickly check. And I'm going to do this on my laptop. So just give me a moment. Now be able to hear through this client from my laptop. I need to find the correct user. Here's an So this is another test, and as you can see, audio is now working, and we're up and running. So I am noticing one other issue with this system. We are still using the self-signed cert. I believe that is the bug with HA proxy, and we can fix that really easily by coming in here, going to our chart for HA proxy to the template files. We go into the deployment and we just need to change this line here. The easiest way to change this is by adding .values, .global, .domain, and save that. And we can run now an upgrade with the value file, the chart files, and the namespace. So what this is going to do is it's going to go in and update just HA proxy and replace the default cert with our new cert that cert manager gave us. And by applying this, oh, we forgot the name. By applying this, we should automatically roll over to it and we will be able to quickly just reload and make sure we have the right certificate. It's upgraded. So we have to go back here. And now I'm going to reload the page. And that should, if we're lucky, go back to the default homepage. So we still have the default cert. And one of the things is that Chrome may or may not cache that file. So what we need to do is okay, so something doesn't seem to be working correctly. So we're gonna get the pods, and it does look like HA proxy is up. So let's describe this and double check we're using the right certificate. Yep, it looks like we have the right certificate applied. So let's just double check and make sure that's a valid certificate, which I believe it is. Yep, we have a valid certificate. So what we're seeing here is just the caching of the certificate. So creating a new window actually gives us our valid certificate. So as you can see here, we're now running a valid certificate. And this is the Let's Encrypt certificate from Cert Manager. Okay, so a few last things I just want to go over. We should talk quickly about updating Rectilium. So if you come into Ret's value file and scroll down, you can actually find the config. So if you want to replace like one or two things, you can do that here. Um, if you would rather leave this part intact, we can come down here. We scroll all the way down. We can highlight all of this. We can copy it. Make sure you get the config and all of this stuff up here. Copy this. We can come back into our main values file, scroll down, and at the bottom here, we can add uh, the ret config that we need. No, not replica. So we can add this. Should tab that over. Just gonna remove these because we only want to overwrite the data. We also need to make sure we have the right name. So this should be William. This needs to match the chart that we have. So this right here is all of the cross-site policy that you will need to modify. There's a lot of settings in here that are from the old Hubs Cloud. So if you need to, you can come in here and add a Sketchfab API key, a Tenor API key. There's really just go through it and you will find the missing settings that are no longer in the admin center. You can also come look at like the extra headers that are needed. You can add your HTML here, your scripts. Lots of things can be configured here. But I will just show you quickly how I would go about, let's say we want to allow youtube.com. So an easy way to demonstrate that the ret config has changed is to actually run this command in debug mode and then output a new file, which I'm just going to call test.yaml. This is due to the fact that there's a lot of YAML files that get outputted for this Helm chart, and my console won't go back that far. So let's just quickly run this. But the chart has run. If we just scroll down here, as you can see, we have our config for ret, and if we scroll down a little bit, getting to our cross origin, right here, you can see the update that I did in our main chart is actually reflected in the output of the YAML. So I would recommend doing it this way so you don't have to go mess around with the subchart. And just know that you can do this for any of the services. And it's any of their configs that are in the subchart. So any value here can be overwritten in your main value file. One thing I do want to go over quickly is the ability to change the client. So if you would like to add a custom client to your hub stack, you need to change this block here. I've described the steps of how to play a custom client in the article. Just know that if your Kubernetes cluster has access to the Docker file, then replacing the Docker registry URL and then the tag with the correct ones by upgrading the stack, you will automatically apply your new client. One of the things that we have available to us is the scale template, and we will just quickly go over it. So we have the values.scale file here, and what this does is it actually goes in and will enable the horizontal pod scaling. And I have it set up here to restrict the resources for Rectilium and all the services. If you would like to run this on a smaller instance, I would recommend not limiting the resources. One thing Kubernetes will do is it will take up all the RAM it can possibly take up. It won't use it, but it will take it up. If you would like to change the auto scaling setup, you can come in here and run this file, and this will enable the horizontal pod scaling. Um, just know that you may need to scale up your nodes as well. For an event, we have another article that is going over all the scale stuff. Just know that the differences in it are that the scale copy uses a C5 2XL. Other changes that it is also using multiple pods for each service. Well, there you have it. We now have a working production ready copy of Mozilla Hub's Community Edition running on Amazon and EKS. I hope you enjoyed this video, and I will see you in the next one.